Today we're going to talk about the mode, the median, and the mean. And I guess I have to start off today with sort of an apology. Statistics can be confusing sometimes. And it would be very nice if statisticians try to help clear up the confusion rather than to help cause it. And unfortunately, there are instances where confusion comes from not only the mix-up between regular words and their statistical meanings, which we've already seen causes a problem, but there's a mix-up because statistics uses the same word to mean different things. The same word means something else depending on the context of its use. And this is very confusing, and it should not be, but it is. And we're here not to correct statistics, but to try and understand what's happening when people talk to us. And so I'm going to have to try and explain to you the right and the usual and what's wrong, and it's going to all be a little confusing for a while. You'll probably, by the time the semester's over, get used to what's going on. But for a while, it's going to cause a little trouble. So try your best to grasp what's true and common usage, and try and figure out what people are saying, even when they misspeak. And it's not just people. You will read in statistical literature misspeaks. Let's get on with it and see what's going on. Remember, we talked about a histogram. Histogram, no real problem. A histogram was, we went out, we got some data, and we observed 5, 6% of the time, and 10, 20% of the time, and 15, 24% of the time, and 20 was observed 20% of the time, 16 was observed 25% of the time, and 14 was observed 30% of the time, and that's our frequency function, our distribution, and so on. Well, what I'd like you to do, now this is going to take some imagination. Maybe you've seen the TV program Star Trek. Well, imagine we're sort of in Star Trek there, and there's a parallel universe. There's two universes. One up in heaven, where everything is perfect, everything is known. And then there's a universe down here where we can't ever know what's up there, but we can take measurements. We can sort of do something which will sort of sneak a peek at what's going on up there. And up there they have a distribution of measurements that can be taken on this book. Here's a book. People are going to take measurements down there. Ha, ha, ha. They're going to get a different measurement each time they take a measurement on the book, and the distribution is going to look, let me draw a picture of it. It's going to look like that. That's the distribution of the data that they're going to get, and they can only read it to every 5th place, say. Well, now, that's what's up there, up in heaven. We down here, we start taking measurements. We observe some 5s and some 10s, some 15s, and we draw a histogram. Now, if we're lucky, our histogram will be pretty closely related to what's going on up in heaven. But we could have been a little off. We could have had a big one here and maybe a small one here, and one here, and then one here, and then one here, and then here, and maybe one out here, and then another one, maybe even another one. So it's possible that a histogram doesn't quite fit the distribution which it's trying to measure. So what you have to remember is there's a true distribution of data, and then there's our peak at the distribution of data, which is a histogram. The histogram is not the real distribution. The real distribution is up there in the parallel universe, in heaven, say. And we are getting a glimpse at it through a histogram. Okay? And if you do that, if you can keep that analogy in your head, you'll have a lot less trouble with what I'm going to be telling you. Because there are parallel universes, and a word in one universe and a different word in the other universe, and unfortunately the words get confused. People confused use them in the wrong place. The only saving grace is that if we're talking about that universe, well, even if they use the wrong word, we know what they mean. And if they're using our universe, even if they use the wrong word, we should know what they mean. Because there are different words in the two different universes. So we are going to have these words. I'm going to tell you how to distinguish the words. But then, when it's used, people will simply use a word, the same word for both. What a mess. But it won't be if we keep in mind that there are two different parallel universes. Okay? Let's do it. Let's define mode. The mode. The mode is the most likely value, the value which occurs most often. That is the highest value in the histogram. Here's our histogram. The mode is the most likely value. This has 1 has likelihood 30%, 2 has likelihood 20, 3 has likelihood 10, 4 has likelihood 5, 5 has likelihood 10, 6 has likelihood 25. Quite clearly, the highest likelihood is at 1, and 1 would be the mode of the distribution. 1, the value 1, is the mode because it has the highest, the most likelihood, the highest value in the histogram. Well, that's not really correct, because there is a distribution up there in heaven. Maybe the distribution in heaven is a little higher on this side than on this side. Heaven would have 6 or maybe even 6.5 as the mode in its distribution. And so there's a mode in heaven and there's a mode here. We should call this the true mode of the distribution, and this the sample mode of the distribution. So there really should be two words. There should be a true mode, and there should be a sample mode. That is the mode, the highest value of the sampled distribution. And the true mode would be the highest value in the real, the true, the heavenly distribution, the underlying distribution. Well, unfortunately, the word mode is used for both instances. And so it is extremely difficult for us to tell which is which unless we realize that if we're talking about data that we have written down, the mode is the sample mode. And if we're saying, well, I want the true value of the highest value of the true distribution, then we're talking about the true mode. And this would be our guess at this. In this case, if this were the situation, we'd be terribly wrong. If 7 were the right true mode and we were guessing 1, our guess would be pretty darn bad. However, that would be if the situation was like this, our guess would be pretty darn close, because the true mode might be here, which might be 1.5, and we're guessing 1, we'd be very close to it. So a mode estimate could be pretty far off. The true mode and the measured mode really do not have to be the same. They could be pretty far off. However, I'd just like you to remember the difference in the two modes. When we say mode, invariably we're going to be talking about the data distribution. We're not going to be using mode much in this class, so we don't have to worry a whole lot about it. Okay, let's get on to the next one. Remember, it was mode, median, and mean. We've taken care of mode. Let's do median. In order to do median, we have to define something called a rank. A rank is a size, place, ordering. If I take people's heights and I put them, if I take basketball players and line them up in size, place, I have a size, place, ordering. I take people different ages and line them up in age. By age, I have a size, place, ordering. Size is not necessarily a length or height. It's a numerical value. I put them in numerical size ordering. Okay? Example. Let's say I had the numbers 1, 5, 3, 2, 1. The size, place, ordering would be 1, 1, 2, 3, 5. We can't really distinguish between the different ones. 1 and 1. One is one of them and the other is the other, and I don't really care which is which. But this is size, place, ordering. So first thing we have to do before we can talk about median is rank the data. Take them and reorder them in a size, place, ordering. Then we can talk about the median. The median is the center of the rank. The center of the rank. And that's not too hard. If we look at this data, the center is, I guess most people would automatically pick 2 without even thinking about it. 2 is the center of the rank. So the example says if the data is 1, 5, 3, 2, 1, and you want the median, first step is to rank them. Do not try and find the median from the unranked data. Never try and find medians from unranked data, because 3 is not the median. rank the data, 1, 1, 2, 3, 5, pick the middle value, that is, equidistance from the two sides, from the low end and from the high end. Well, this will only work if there's an odd number. What happens if you have an even number, like 1, 5, 3, 2, 1, 4? Put them in size place, you get 1, 1, 2, 3, 4, 5. Going in from both sides, you end up with 2 in the middle. Well, the median can't be two numbers. So what we do in a situation like that is simply go in between them. In between 2 and 3 is 2.5. So if this were 2 and 4, then the median would be 3. If this were 2 and 10, the median would be 6. I think, yeah, 6. You go right in between the two, right in the middle. That's how you get the median for an even number. This is how you get the median for an odd number. So now that's not very hard finding the median. There's only one little problem. There's only one little problem. That's the median of our data. But this is just 5 numbers from an infinite set of numbers that could have been picked. Somebody else picks 5 numbers, they'll get a different set, and they'll get a different median. Someone else picks 5 numbers, they'll get a different 5 numbers, they'll get a different median. But there is a median up there in heaven, in this parallel universe. If you took all the conceivable data and moved in from the two sides, the 50th percentile, the very center of that data, the 50th percent of the data, would be some number. That's the true median. What we have is the sample median. Well, the true median and the sample median, they're quite different. They're certainly not the same. Yet we have only one word for them, median. So when we say median, we have to sort of say to ourselves, well, what are we talking about? The data median or the true median? The data median is our guess at the true median. See, we took a sample of size 5, best we could do, all we could afford. Okay, let's look at the middle of it. Middle of it's 2. Okay, I think the true median is somewhere around 2. I know it's not exactly 2, I'm pretty sure of that, but it's close. This is what's going on. There's a true median, there's a sample median. Okay? Let's draw a picture of it. The true distribution looks like this. The true median is the 50th percentile. That's if it's symmetric. If it's not symmetric, if it's got a long tail, the true median might be here. We just have to have 50% of the area on each side. 50% here, 50% there, 50% here, 50% there. And when we find the middle, that point at the middle would be the median. If we have some data, we take some numbers. We make a sample here, and a sample here, a sample here, and a sample there, a sample here. This would be the middle number. This would be the median of our data if it were the center of 5 numbers. This is not exactly this, but it's our best guess at that. So the sample median is the best guess at the true median, and that's why we use the sample median. And people just slur over the difference between the two, but there is definitely a difference. There's no question about it. Okay? Now, this next one, so far there's not a whole lot of problem. You're saying, well, there's a sample median, there's a true median, and we use the word median for both. I can follow that. The next one will cause a little more trouble, because there are 2 different words for the parallel universe and for us, for heaven and for us. And those words are used, unfortunately, interchangeably. People just don't really discriminate. They use the wrong words at the wrong time. And we have to then sort of realize, the poor guy who's being bombarded by all this stuff has to realize what's going on and straighten it out in our own heads. All right? The next word, mean or average. And for a little while, I'm just going to use mean or average like everybody else does, as if they're the same. But mean and average are not the same. They are not exactly the same, although frequently you will find them used the same and used interchangeably. They are not interchangeable, but they are interchangeable in slang and everyday language. So let me just define what's meant by the mean or average. Actually, right now I'm defining the average. You take all the numbers and you divide by how many there are. That gives you the average. Everyone knows that. That's how you average things up. You add up the numbers and divide by how many there were. Gives you the average. Example, 1, 5, 3, 2, 1. Add them up. 6, 7, 8, 9, 10, 11, 12. 12 divided by 5, 2.4. 2.4 is the average, or what people would call the mean. The mean, they say. That's the mean. 2.4 is the mean. Actually, it's the average. This mean or average is answers the question, what one number could replace all the numbers but keep the total? See, these other measures, median and mode, once you're given that number, the rest of the numbers disappear and they have no way of getting them back. Well, what if I'm interested in the total number? I wanted the sum. I want to keep the sum. You can always get the total back merely by multiplying the average by how many data points you have. That gives you the total back. Well, what's going on here is everybody in the classroom has some money in their pocket. Okay? That means in the classroom is a total amount of money that we can raise for a charity. So everybody puts that money on the table and there's $300 in the pot. Well, there's 300 people in the class. That means each person had $1 on the average in their pocket. So the average was $1 per person. On the average, everyone put in $1. But they didn't. Some had a lot of money, some had a little money. Well, we've got this average now, $1 per person. That's the average. And someone says, oh, gee, I forgot how much money we collected. How much money did we collect? Well, if we had given the median amount that everybody put in, that if we took the amounts everybody put in and lined them up in size place and took the median, we'd never be able to figure out again how much the total was. The median will no way tell us what the total is. The mode. What was the most likely amount given? More people gave $1 than any other amount. Well, okay, that doesn't tell us what the total collected was. However, if the average is $1 and there are 300 people in the class, then the total amount collected must have been $300. So the average is the one number, the one estimate of center of things, which could keep the total intact. Okay? That's one nice property of it. Another property of average or mean is that it's the balanced center of the data. Now here, I'm saying of all the data. Now here's where the trick comes in. Here's the difference. Let's talk about the data we have. Here's my data points. There's 100 data points. I take each data point, each time someone makes an observation, I take a penny and I put it on sort of a weightless stick. Put a penny on the stick. Someone, this penny here, and a penny here, and another one, another one, another one, another. Each time someone observes something, I put a penny. Whoops, got to start at the bottom. Put a penny on the stick, and when I'm all done, I have a pile of pennies on my stick. Now the problem is, where do I balance that? So I run a knife underneath it, and finally, somewhere, I can just balance that batch of pennies. That balance center is the average. The average is the balance center of the data. Well, what does the mean? Is that the balance center of the data? Well, yes and no. If we go to the parallel universe, there's a whole but there's a lot more data, an infinite amount of data, and it's nice and smooth. It doesn't have jagged edges. It's nice and smooth, and it's filled in with pennies or very small weighted pennies. And where will that mass of stuff in the parallel universe, in heaven, where will it balance? It may balance right there. That is the center of all the data, all the data. If it's the center of all the data, it's the mean. The mean is the center of all the data. The mean is the average of all the data. If you took all the data, this infinite amount of data up in heaven, added it up and divided by an infinite, you would get the mean, the true center. The true center is the true balance center of all the data. That is the mean. The true balance center of all the data is the mean. The balance center of the data we happen to have collected, that's the average. The average is the balance center of all the data we've collected. That's the difference between the mean and the average. The mean and the average differ by the fact that the mean is the average of the data up in heaven. All the data. And the center of all the data is the true meaning of the width of the book. If we're taking measurements on the width of the book, and there's some values are bigger, some values are smaller, the true width of the book is really the center of all possible measurements taken on that book. So the value of the parameter, what we're trying to measure, is really the center of the distribution of all the data that can be taken on that book. And that is the mean, or expectation, as we'll learn. Okay? So the mean is the center of all the data, and that center of all the data is by definition the value of the parameter that we're measuring. See, we're measuring the width of the book. there's no one number that represents the width of the book. There's lots of possible measurements that are numbers that can be taken on the. Well, if you took an infinite number of measurements and made a distribution, the center of that distribution would be the true width of the book. That's the mean. The mean is the value of the parameter. The mean is something we can never know because we can never know the value of the parameter. The mean is the center of the data up in heaven, not here on earth. And here on earth, the center of the data is the average. Average. Now, you'll see books say, what's the mean of your data? Well, the mean of my data is 2.4. You know what's meant. What's meant is what's the average of your data? Because you couldn't possibly get a mean. You have to have an average. They say, well, what is your 2.4? Give me an estimate of the mean. Now that's correct. That's a proper use. Someone says, give me an estimate of the mean. And that to you means, hey, they're talking about the center of the distribution of data up in heaven. Well, of course I don't know that, but I can estimate it. I can guess at it. I have data here on earth. It has a distribution. Distribution is fairly close to the one up in heaven, I hope. And I'm going to use my average. My average estimates the true mean. So the average is an estimate of the mean. It's the best estimate of the mean we can have. But it isn't the mean. But people will say, give me the mean. What you give them is the average. And nobody's going to argue with you because that's what really they were asking for. Give me an estimate of the mean. Give me your average. Okay? Let's summarize what we did. The mode, the most likely value. So if we have this underlying distribution up there in heaven, the true mode is the highest point in the distribution in heaven. And if we have some data here on earth, the highest point in the data on earth is our mode, is our sample mode or our mode down here. The rank, a size, place, ordering. Just order things, put them in size, place. The median is the center of the rank. Now again, the center of the rank is where 50% of the data is on one side of it. That would be the median up there in heaven. And if you take all the data, put them in size, place, and find the one in the center, or if you have two in between the two in the center, that would be the median of the data here on earth. And of course, all earth values are estimates of all heaven values. The average is the sum divided by n, and the mean is the balance center of all the data. And the average is the balance center of our data here on earth, which happens to be the sum divided by n. And frequently, remember that these two words are interchanged in the literature. For some strange reason, they can't keep them apart. Now we can understand how these two get confused because there's only one word for the same, for two different things. But here there's two different words, and yet they're confused. And we have to get used to it. And hopefully you will get used to it, and there'll be no problems. Okay? See you next time.